Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. A little bit about what Data Unchained and this podcast is all about. The paradigm for data access has really changed over the last several years. There was the advent of the cloud, then COVID came along, and remote users became really a standard type of environment that organizations and data-driven workloads are trying to grapple with. And that's what this podcast is all about. In today's decentralized world, how do we get data to distributed applications, remote compute sites, and into the cloud? Data Unchained digs into the challenges as well as the solutions into making data a global asset. Today, we have a longtime colleague that I've worked with from Hyperion Research, Mark Nossokoff, joining us. Mark is the research director over there at Hyperion and joining us from Colorado. Thank you for joining us today, Mark.
Hi, Molly. Thanks for having me. Glad to be here.
So before we jump into Hyperion and talking about data, can you tell us just a little bit about your background?
Sure. As you indicated, I'm currently a research director with Hyperion Research, but in the past, I come up out of the data storage realm. I spent a number of years designing, marketing, strategic planning for data storage systems for both enterprise workloads and HPC applications and workloads. That encompass both engineering activity and marketing activity and strategic planning of the solutions and technology.
So it seems like, Mark, with the background that you have, that I've also been in HPC for a long time, and for a long time, it felt like things didn't change that fast. Lots of innovative research was coming out of HPC, but in the architectures themselves, aside from faster devices, faster networks, faster compute cycles, HPC really didn't change that much until just recently. Is that how you've started to observe it as well?
Yeah, to a certain degree. Certainly, a lot of the technological and architectural advances start at the high end in the HPC space, from the leadership computing driven largely by some of the government labs, driving faster processor speeds, the newer networks, the need for higher capacity and faster storage devices. But the workloads themselves had been largely the physics-driven modeling and simulations for whether it be for new manufacturing area of automotive and aerospace, and new product design. But more recently, with the advent of AI and workloads driving different types of profiles that are running on these machines, are also driving new requirements for the architectures. And maybe I should back up a little bit too and kind of explain what HPC kind of means to us. The hardware is interesting and certainly fascinating, the speeds and feeds and all the various elements that go into it. But as we look and talk about HPC, it is more about the workloads that are running on the machines and on the architecture. It's and maybe it's also helpful to describe what HPC is not. I mean, it's not your running your payroll. It's not the email system. It's not the general ledger accounting. It is the advanced type of engineering and science and research that's being done to try to solve some of the largest problems addressing the world today.
And I think that's an interesting evolution. You talked about the physics types of workloads, particle accelerators, all those types of things. But when you look at the HPC market today, do most enterprises use HPC technologies or just a subset?
I would say it's growing. Traditionally, the HPC has been used largely by the large manufacturers, car manufacturers, airline manufacturers, in the bioscience and healthcare area as well, in the studies to identify cures and vaccines for various maladies. But more and more, as AI is being adopted, what would have been considered more the traditional enterprise IT, they are finding ways to apply and adapt AI to their businesses. And that type of AI workload requires a different type of architecture and support structure and data sharing environment than what traditional enterprise IT has infrastructure and data centers provided. So we are seeing an uptake and an increase of the of the user base, if you will, adopting more HPC oriented architecture than just the traditional government labs or large scale manufacturers.
Yeah, I find it interesting. We have a lot of very smart, talented people who join this podcast. And just in the last few episodes, we've had folks join the podcast that are not just experts or PhDs in their line of business. So whether it's genomics PhD or something like that, but also have a long history in HPC. And it's interesting that dual role, whether it's an animation studio who is creating Hollywood content and using HPC to render and process jobs, or if it's a PhD in genomics research who's building out an infrastructure to share COVID data. It seems like that dual role is becoming more and more common, and we need the HPC technologies for them to really get their work done.
Yeah, exactly. And I think some of that's driving some of the evolving architectures, because each of those areas require and placing different and new demands on the architecture. So, and not only demands on the architecture, but where the data is being created and utilized and shared is maybe even the larger change that's occurring in recent years.
So Hyperion recently produced a paper, and we'll include it in the show notes for folks to be able to access it. But we'll be talking about it a little bit here in today's podcast. In 2023, if you can kind of just summarize kind of the workloads and how AI are going to influence HPC, maybe we could start there.
Sure. I mean, the various workloads, especially AI, are just driving huge demands on the systems. The vast amounts of data that are being collected to be able to drive accurate AI models, and where that data is being generated, whether it's data being collected from the satellites for the large scale array for astronomy and type of research, or I just saw a use case today where the video camera is located all around cities that are capturing real-time streaming data that's then processed to identify obstacles to better help visually impaired people traverse the city in a smart city kind of application. All of those are new. Oh, well, the astronomy one isn't quite as new, but certainly the smart city one is much more recent and driving different requirements for processing the data, for training these large scale AI models, and then making the models available and useful for the users and application of them.
So where do these AI models run? Are they something that HPC institutes have in their data centers? Are they taking advantage of cloud technologies?
It's a bit of both. I think there's an awful lot of AI activity occurring in the cloud now, as much for experimentation and understanding of what users can do and organizations can leverage for. The organizations don't know yet the power of it, or the application of it, or what their actual requirements are. So the ability to leverage the latest and greatest technology that's afforded and available to them via the cloud for them to learn and understand for their various use cases is quite attractive.
I find AI interesting, of course, with all the chat.ai and different types of technologies like that. They're in the news right now. I think everyone is reading about it right now, and we've certainly been hearing about it in movies and everywhere in between for the last several years. But how is AI really being used? What is the output of these models doing to science or doing for enterprise?
Well, it's interesting when we think about the overlap and intersection of AI and HPC. We kind of think about it in two different perspectives. There's HPC-enabled AI and AI-enabled HPC. So the HPC-enabled AI is taking the infrastructure and these machines and making them available for the models to be developed and run, and just processing the massive amounts of data for to get the accuracy needed to reliably and confidently be able to support the self-driving vehicles and other types of applications for AI. On the other side, the AI-enabled HPC is the notion of taking a look at large data sets, but then the large number of different types of simulations that can be done either for Monte Carlo analysis or maybe even some of the weather forecasting and items that go into weather forecasting. And rather than doing a brute force HPC, large scale modeling and simulation across the entirety of the data sets and data points, AI can help identify those areas that are most likely to produce the best results in the model, and thus limit the amount of data that needs to be go through the brute force process and get the work done faster, get it done more sustainably using less energy if it's being done faster. So there's all sorts of benefits of AI from that perspective too.
Interesting. I think about with some of the customers and programs that we work on at Hammerspace, where there really is different ways that AI is being implemented. And some is on distilling which data is even valuable to go do something with. And then there's the other part of, okay, I want to do something with it. Now let's process it and get interesting results out of it. And that leads to technology is often running in a lot of places. Some is at the edge, some is in an HPC center, some is in the cloud. When you think about data is everywhere and an organization is trying to get information or results off of it, what kind of pain points are you running into related to sharing, security?
Yeah, so there's a number there. You mentioned two of them, the sharing and the security. And there's at the end of the day, what may be the most important is the cost aspect of it. Where is the data? Where can it be best? Where is it needed? And when is it needed there? So we'll back up a little bit and kind of unpack each individually. The security aspect of it is, the data can be a company's business. So being able to protect it and only have those folks access it that are able to access it. There's also compliance and governance issues that need to be considered, whether it be country level or regional level. For certain types of data can only stay within certain regions. So those aspects need to be identified and understood. There's the flip side of that. There's the notion of the data. The more people that can access and process the data, the more beneficial that data is. So a collaboration aspect in being able to get all of the data in a timely fashion, economical fashion, reliable fashion to all the sites and constituents that can act upon it and generate the research, the science, the engineering, the video content, all the better. Then lastly, I mentioned the cost aspect too. That in going to the cloud, having access to the latest and greatest technology is of a great value to users. But sometimes what's not always visible, not always transparent, is the cost of the data and the data movement for getting it to where it needs to be in the timely fashion. So sometimes it's good to move the data to the compute. Other times it's best to move the compute to where the data is, to have at least a first order analysis of processing on the data before it gets passed up onto the cloud or back to an on-premises data center.
So with the rise of data orchestration systems who are moving data around, creating metadata that's maybe being enriched by AI, things like that, how is that changing HPC? Do you think that we're going to see this kind of critical mass around an HPC center? Do you see that it's maybe kind of not in the cloud per se, but that it's going to be a lot more nimble? Do you have any predictions on that?
Yeah, I think it will be. I think there will always be a need for on-premises HPC infrastructure for the sites and organizations that have a very focused activity that can really utilize a large percentage, 80-90% consistently utilization of their system. It can be more cost effective and more economical to run their workloads on premises. But as some of the cost of the especially the leadership class systems continue to increase, and the utilization might not be that as high, then the nimbleness and the flexibility and being able to dynamically utilize resources in the cloud becomes more and more attractive. Both from a just the raw costs of the infrastructure, but also the management of it. Do organizations want to invest in the knowledge of the HPC and running the HPC, and do they want to deal with the actual physical plant of power and cooling and that aspect of it, or are their resources better spent on their core competencies, and then being able to leverage a pay-as-you-go model and leverage other sites that their area of expertise is more tuned to the infrastructure and provisioning of the resource.
You were talking about, it sounds super complicated, and we're definitely in a world where, with the idea of SaaS applications and tools to simplify access to technology, are you seeing that HPC is becoming more accessible to those who don't know how to build out these systems and write the applications and all the tooling?
Yeah, absolutely. It's from a number of perspectives there. You mentioned that the SaaS, the software as a service, or also you also hear infrastructure as a service and platform as a service, and even HPC as a service in some circles. But they each give users a kind of an entree or entry point into the level of expertise they want or think they need to have. This also kind of touches too upon a trend that is an unfortunate trend, is it becoming much more difficult to identify and retain HPC talent, to be able to set up, understand, identify the architectures, set up, maintain, deploy the HPC itself. So this as a service helps both financially for those that don't have the capex to really invest largely on site and move it more to an OpEx model and a pay-as-you-go type model, but also allows a more focused stream for their resources investment to focus on their core competency versus maybe something that they can better outsource.
That makes sense. Where does the edge fit into all of this? Data, I think we all would agree that there's a massive amount of data, maybe more data being created at the edge than anywhere else these days. How does that fit into these architectures, the idea of, you want to process some data to be able to drive results, whether it's a physics project or anything else? Or is much of the data from the edge being included in that?
It more and more it is. The use case I mentioned earlier, as far as the cameras mounted on streetlights and stoplights, doing the capturing that real time video that then gets sent back for the processing, either in the edge server, a near edge server, or to train the model back in the cloud or on prem, that then updates the inferencing that can occur to help the visually impaired navigate the city. You've got I mentioned the square kilometer array as well, capturing all of the data from what it's collecting from scanning the skies. Another recent, I just came back from visiting a couple of sites in Europe, and one of the weather sites commented that they are gathering data from 800 million data sources a day, 800 million sensors or sources from globally that then feed in and come back into their ensemble of simulations that put together the weather forecast model. So the edge is there. It's kind of always been there, but it's even becoming more critical as some of these AI type of applications are being deployed in manufacturing quality control, or other types of smart city applications, retail applications, real-time marketing as targeted marketing for various applications as well.
Gotcha. So I'm at my company kickoff meeting right now. I'm out in Santa Clara, and Blue Origin was here talking yesterday and talking about kind of some of the concepts that we've been talking about here today. But then it seems to be a common theme now that people are starting to think about what does the edge look like as it gets out into space, whether it's in lower Earth orbit, deep space, and people are starting to think about these things. And if we had a base on the moon, how would you get data to and from it and things like that? And I know you're fortunate to get to speak to a lot of folks at companies like NASA or organizations like NASA and whatnot as well. As you think about what's coming next, do you see those types of challenges starting to be tackled as well in the HPC community?
Yeah, I think so. That's certainly a factor being considered in their next procurements and how to best outfit their infrastructure. I mean, you can I think wasn't HPE put their spaceborne computer is up on the International Space Station now, so one could argue that it's kind of already started.
Interesting. I didn't know that. That's interesting.
In a very real sense. For some types of activity there.
Yeah, I was looking at AWS recently launched a satellite ground station kind of ingest point for satellite data to get efficiently to Earth, and then it has AI processing to figure out which of that information is valuable, so then can get passed along. That's something I'm really excited about that I see coming down in the industry. What other trends do you see coming up that you're excited about?
Well, just all sorts of what the smart people are coming up with to utilize the all the power that's coming about from the new technologies in HPC. The life science and bioscience area is fascinating, just from a public health and safety aspect, from being able to quickly identify causes of illness and then really do pinpoint where to look for the vaccine and or cure for something. The development of new and unique materials to for various whether it be battery designs for greener energy, other types of what's being done in the various weather and climate research activity to address sustainability from a number of aspects. Just the application of everything for the betterment of society is exciting.
It definitely is. So as we wrap things up, can you point to a few places as folks who listen to this show are looking to learn more, maybe delve into some of the research? Where in the Hyperion research or other places in the community should they go to learn a little bit more?
Well, I think Hyperion is a good place to start. We are a market analyst, industry analyst, market research firm that provides insights into HPC, and we use HPC kind of almost as a catch-all that also includes the related activities of quantum and AI and cloud adoption. We also promote and sponsor the HPC user forums. You mentioned, I think, one earlier we had recently in Paris. We have one coming up in April in Princeton, New Jersey, that folks are welcome to attend and learn more. There are various news outlets that continuously cover the industry inside HPC. HPC Wire are two in particular that are cover the industry very well, and so there's lots of opportunity to learn and grow in the HPC knowledge.
Excellent. Well, thank you for joining. For those of you on the show, we'll be including a link to the 23 predictions in the show notes if you want to go take a look at that. And then, Mark, if an enterprise, an IT architect, whoever it might be is listening to the show, is interested in engaging with you personally, is there a way to speak to the analysts at Hyperion, or is it kind of gated through your website and through your research content?
Well, we do. It is somewhat gated. We're happy to respond to inquiries. You can, in the show notes, feel free to please provide my name and contact information. I'm happy to talk to folks directly. We also have the info at Hyperion Research, HyperionRes.com. that folks can access. The website has certain amounts of information, and then I also mentioned the HPC user forum has its own independent website for various content and education as well.
Okay, great. And I definitely will make a pitch for the user forum myself, that I attend those as often as I'm able, and I usually am able to comprehend about 70% of what's discussed. Is some really smart people building quantum computers and whatnot. But what's great is this community's been deploying large-scale data solutions and data insights for decades, and is a great place that we can all go to learn from that knowledge, and a great place where you can ask questions of those who maybe been doing it for a while. So I definitely recommend looking those up. Mark, thank you for joining the show, and to all of our audience, thank you for downloading this episode.
Okay. Thanks, Molly. Appreciate it. You take care.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.